the topic for today is photoelectric effect. So we are familiar with the reverse effect. So इसको reverse effect में we are actually familiar. We are familiar with electric gives photon or light. So when we supply electricity to something, right, we are exposed. We are known to the fact that when we supply electric current to an electric bulb, we get light as a result, right? But now this is the reverse of this. So when we supply light to something, light to some material, we get electricity, right? So this is known as the photoelectric effect. So for the photoelectric effect, we need to understand an experiment. Okay, it's a very simple experiment, but very important experiment. So let us try to understand that experiment. So in the photoelectric effect, what we have is, so we take a cathode and an anode, right? But we don't directly connect it to battery. So we have a cathode here, and we have an anode here. And this is, what is cathode? Cathode is a negative to positive electrode. Cathode is a negative electrode. Cathode negative one, right? And then we have anode here, and we have something to measure the current, right? So we have something, let's say we have ammeter to measure the current here. We have something like this, right? This is the cathode, this is the anode. Now what happens in photoelectric effect is, we need to study the effect of photons or light particle, light on some material, whether light can influence current to flow. So basically, what is current? Current is basically flow of anything, right? Flow of anything whenever there is some potential difference or potential gap between 2 points, right? So it can be flow of water, it can be flow of air, it can be flow of anything, right? Here we are considering flow of charges. So when we consider flow of charges, it's called electric current, and we are trying to find whether light intensity or like light falling on a particular substance can influence, whether or not it can influence the flow of current through something, right? So whether it can allow or not allow the flow of current in a particular substance, right? Substance or material, whatever you call it. So now I have placed a cathode, right? Cathode, which I want to test whether it is photoelectric or not, whether it exhibits photoelectric effect or not, right? So I'm trying to test the cathode. Anode is not that material. We are not trying to test with the anode. We are trying to test with the cathode, because cathode baneko is the negative side of the electrode, and negative means there is some excess of electrons, and we want these electrons to flow through the circuit, right? And this is known as this is a battery, right, that can later act as the accelerating or retarding potential, which I'll explain later. Retarding potential, right, it can act as accelerating or retarding potential. Now this thing is black, completely made black from all the surfaces except from one side. So all other surfaces are completely black. Epicharical surfaces are all completely black. No light is allowed to touch the cathode from anywhere except from this side. So light is only allowed to fall from this side, right? And we are trying to measure whether this can show a deflection in the ammeter or not, right? So this battery is already there in the circuit, so its reading will be already measured in the ammeter, and we can calibrate the ammeter accordingly. So we can make the ammeter not record this current flowing through this battery, right? The battery causing the current to flow. So we can calibrate it in such a way, right? So when light is focused on this cathode, and this cathode is a photoelectric material, which means it is a material that can produce current when exposed to photons or light, then we see a deflection in the ammeter. It's obvious, right? If a material exhibits photoelectric effect, then we obviously see a deflection in the ammeter, which clearly concludes that there is current flowing in the circuit that is due to the light, right? Because of light falling on particular material, the thing is deflecting, the ammeter is deflecting, which is showing that there is some current in the circuit. Now, when can this act as an accelerating potential or a retarding potential? So now, if I keep the cathode at negative bias, so if I keep the cathode continuously at negative, right, and I keep the anode continuously at positive, which means the potential difference between these two will keep on getting higher, right? Because if this is a photoelectric material, अगर ये photoelectric material हो भने, this material will constantly push out electrons, right? It will constantly push out electrons, meaning this side will constantly be more negative and this side will be constantly more positive. So now this battery, when placed negative towards the cathode and positive towards the anode, will act as an accelerating potential, which means there will be more deflection in the ammeter. You will see more and more deflection in the ammeter, which means there is more and more current flowing through the circuit, right? Now, when will it be a retarding potential? It will be a retarding potential when you flip the battery over. So when you remove this battery, and now what you do is you place positive to this side and negative to this side. So now what happens is, this is constantly making this side negative, but the battery is constantly forcing it to be positive. This side is constantly trying to be positive, but the battery is constantly forcing it to be negative. Now what will happen is, the ammeter will show less deflection because the forces or the flow of charges will cancel each other, right? It may not completely cancel each other, but this will overpower this one. It will overpower this one because
The
like,
question.
yes, please.
मैले इन केस ब्याट्री थिएन भने पनि एमिटरमा डिफ्लेक्सन देखाउँथ्यो लाइट हालेको थियो भने
That, like, you know about amplifier circuit, right? So what is the amplifier circuit? So speakers here, one amps, amplifiers. So amplifiers are basically when you speak into a microphone, that microphone catches very small signals, right? It has to like activate the piezoelectric sensor inside the microphone, right? It has to convert the mechanical energy that is coming from as sound, right? Sound is basically a mechanical wave. So that wave has to be converted to electrical energy. But that wave that goes inside the microphone is very, very weak because it's just air in front of us, right? And the energy loss in the air, like after every layer of air, is like extremely high. So it receives very small amount of faint current. But still we can, like, when we speak in front of the microphone and connect big speakers, we hear like we can control the amount of sound that comes out, right? We can make it very loud, we can make it very soft, right? So that is the job of an amplifier circuit. Now this will act as an amplifier circuit, okay? So it does not necessarily mean that if I remove the battery, I'll not get any reading in the ammeter. No, that assumption will be completely wrong. But I may not get as well, because it, like, the current may be extremely small, right? So no one knows what is the extent of the current that happens due to photoelectric effect. ठुलो basic current हुन्छ या त कम्ती current हुन्छ. So this thing acts basically like an amplifier circuit, right? So it can amplify, it can act as an amplifier circuit to detect the current flowing in the circuit, right? So you can remove it if your photoelectric effect is high, right? If you are getting more current, then you can just remove the battery and just place the ammeter there, okay? But if you think that your photoelectric effect is not happening that precisely and it's not like 100% efficient, then you place a battery for amplification. Is that clear?
होइन भनेपछि रिडिङ आउँछ तर हुन सक्छ हुन सक्दैन
Exactly. कम्ती होला. It can be extremely small, which may not be detected by this ammeter, right? So for that we are just putting a battery that may act as an amplifier circuit, okay? So now you yes, one
तैँले भन्नु नि यो ब्याट्री हालिसकेपछि अब करेन्ट त फ्लो भइरहेको छ नि त.
yes, correct.
एमिटरमा रिडिङ त देखाउँछ नि यो उयो थिएन भने पनि.
के थिएन भने photoelectric effect नभएको भए पनि yes देखाउँथ्यो. तर what happens is I'm calibrating the ammeter such that it will not show deflection. It is fixed at particular point.
उयो जस्तो वेटिङ मसिन जस्तो.
Exactly. एउटा वेइङ मसिन जस्तै. करेक्ट.
वेटिङ मसिनमा मैले 50 केजी भने मैले त्यो 0 मा उयो गर्दा हुन्छ नि.
करेक्ट, एक्ज्याक्टली. इफ यु 50 केजी नै हुन्छ. सो द्याट इज डन टु ट्रिक कस्टमर्स नि त. 500 ग्राम हालिरहेको हुन्छ, दे जस्ट press a button, it will calibrate to 0, right? So same thing, and like same कुरा, the ammeter will not show any deflection with the battery, okay? The battery current will not affect the ammeter, only if there is some opposing current or forwarding current. So if the current is opposing, like it is a retarding potential, so something like this is a retarding potential. when the cathode is given the positive side of the battery, then it becomes retarding, because the direction of the electron flow will be different. They'll cancel each other, right? And the value of ammeter reading will decrease. And accelerating potential is when negative is connected to negative, so it'll influence the ammeter to show more deflection, more current. Okay, so this is photoelectric effect. So photoelectric effect is basically some materials have the tendency to allow electrons, right, electrons to freely move when light is shined on them, light falls on them. So that kind of effect is known as photoelectric effect. Photoelectric, photo comes from photon, so photon is influencing electric movement, right, electric current. So photon भनेको light, light is influencing electric current in a circuit. So that is known as the photoelectric effect, and that is explained by this diagram. It's very simple. Now we have one more thing to study now. Now this is photocurrent. I think this is photocurrent, right? Yeah. This side is photocurrent. This is photocurrent. PHOTO, photo current, and this is potential. But okay, this is potential, this is photocurrent. Now we know that when the potential, there is a graph which you need to study. Okay, so there is, let's say, a negative potential of 1.5 volt. It's not necessarily 1.5. okay, I'm just giving an arbitrary value. So there is a graph something like this, and this value is known as stopping potential. Now this is a direct application of the retarding potential thing. So what I told you about retarding potential. So retarding potential is when I connect the cathode of the photoelectric emitter. That cathode is connected to the positive side of the battery, and anode is connected to the negative side of the battery. So which means that there is opposing currents, right? So that opposing current will completely stop the flow of current in the circuit at a particular voltage, right? And that voltage is known as stopping potential. Is that going in your head right now? So I had told you about this type of configuration, right? So when positive is this side and negative is this side, so which means there is opposing current here. So ammeter reading will decrease. So as the voltage if we increase, if this voltage is variable, right? If this voltage is variable and we try to increase the voltage more and more, at a particular voltage, the photocurrent will completely stop. It will be completely zero, and that potential is known as the stopping potential. Is that clear?
एकैछिन दा
Okay.
त्यो अर्को फोटो अहिले हेरि नि ग्राफ हैन त्यो सर्किट.
Yes.
पोजिटिभ एनोड भइहाल्यो.
Positive anode. Yes, this is anode. This has to be anode, but we are connecting this to negative now.
नेगेटिभमा भयो. अनि लु पोजिटिभ उयसमा छ. मेरो फोटो इलेक्ट्रिक इफेक्ट देखाउने उयसमा छ.
Positive मा छ हैन मेरो. Yes, positive मा छ.
अब नर्मली के हुन्छ, सर्किट क्लोज छ भनेपछि इलेक्ट्रोन्स विल ट्राई टु फ्लो फ्रम
नेगेटिभ टु पोजिटिभ. यस,
पोजिटिभ जानु खोज्यो. तर मेरो उयसले के भन्छ, यो जुन लाइटले छ नि, लाइटले उयो गरिदिँदैछ, मलाई दिँदैछ. अब
लाइटले इलेक्ट्रोन निकाल्दैछ, राइट? इलेक्ट्रोन इज कमिङ आउट फ्रम दिस. बट बाटोमा के छ? पोजिटिभ छ, एबन्डेन्स अफ पोजिटिभ मिन्स होल्स, राइट? सो होल्स. सो इलेक्ट्रोन्स गो एन्ड fit in the holes, which means they neutralize हुन्छ. Yeah, they neutralize in the way itself. They don't reach the ammeter पुग्दैन, right? So when this voltage is low, your voltage comes this up. When this voltage is low, some electrons may escape this, because most of the electrons come and fill it. Yes,
त्यति बेला के भन्छ, यो जुन एलिमेन्टले फोटो इलेक्ट्रिक इफेक्ट देखाउने एलिमेन्ट र यो के भन्छ ब्याट्रीको पोटेन्शियल त सेम हुनुपर्छ त्यति बेला त.
it has to be. Yes, yes, yes. It has to be same. Correct. So
The same
photoelectric
amount
volt.
of current
एक्ज्याक्टली एक्ज्याक्टली जति इलेक्ट्रोन यहाँबाट निस्किँदैछ त्यति इलेक्ट्रोन यसले एक्सेप्ट गर्न सक्नुपर्छ करेक्ट करेक्ट द्याट इज करेक्ट सो द्याट
त्यो
द्याट
पोइन्ट
इज
चाहिँ कहाँ हो ग्राफमा त
त्यो पोइन्ट यही त हो त दिस वान
दिसन होइन ए
यस बिकज हियर एक्चुली इट इज स्टपिङ सो इलेक्ट्रोन कमिङ
होइन
एन्ड
यति
द यस
यति बेला चाहिँ के भन्छ दुइटाकै पोटेन्सियल सेम छ त्यही कारण उयो नभएको के भन्छ
electron
current
flow
flow
number.
नभएको
Yes, exactly. So that is the stopping potential. So at this point when there is no voltage applied, so if we this point is where no voltage is applied, right? So voltage is in the x-axis. So x-axis no voltage. So we have no voltage applied to the photoelectric circuit, which means now the current is at this point. So let's say this current is around 3 microampere. Okay, so 3 microamps. Now achanak we start applying a negative voltage to it, which means we are applying positive to the photoelectric emitter and negative to the anode, supposedly anode, right? So now what happens is current will keep on decreasing and it will reach to a point where the potential balances and there is no current flowing through the circuit. So ammeter doesn't respond to anything now. So that is the point where the stopping potential, this what voltage is known as the stopping potential, right? So now from this point the voltage is increasing when we go right? So voltage is like constantly increasing. So what happens when voltage increases? So when that voltage is increasing in the positive direction, so it is influencing more current to come through it, right? Because it is in the same direction of the circuit. So it'll
यो
increase.
पोइन्ट हुन्छ नि यो
Yes.
3 माइक्रो एम्पियरमा
Yes.
यति चाहिँ मैले के भन्छ फ्लिप गरिदिएको छु ब्याट्रीलाई
No, यति बेला you don't have a battery. No, you don't have a battery at all. There is no battery at
तर
all.
त्यहाँदेखि उता चाहिँ छ
Yeah, this side you are flipping. You are making positive ulta and negative ulta. This side you are keeping in the same direction. So the cathode, the emitter and this negative is on the same side. So this is, so what you have here, this is this one. Matlab, in a photoelectric emitter, if that is connected to the negative side of the battery, then that is represented by this side of the graph. And that is known as acceleration, right? And now when this is connected to the positive, this is connected to the positive, and the other side is
बढेकै हुन्छ
potential बढ्छ एक point in stabilize हुन्छ. From this point it's stabilizing, it will be constant.
पोटेन्सियल त बढ्दैछ नि
Potential बढ्दैछ, battery potential is increasing, right? But the current is remaining the same after some point. So photoelectric current will not depend on the external voltage from a particular point. Okay.
नै भनेपछि पोटेन्सियल बढेकै गर्छ
Potential बढाकै गर्दा हुन्छ, the current will not increase. You can increase the potential as long as you want, the external potential of the battery, but the photoelectric current will not increase. Okay. So photoelectric current, there are various factors in which photoelectric current will depend. Okay, there are a lot of factors in which it depends. We'll discuss about two important factors, and that thing is also known as, what is that called? Law of photoelectric effect. Yeah. So that thing is known as law of photoelectric effect. So law of photoelectric effect. So we did retarding potential, we did accelerating potential, we did stopping potential, right? So now we do the law of photoelectric effect. So photoelectric effect is basically based on by applying light or by shining light to something and trying to free some electrons, right? So electrons are getting freed, right? So we can logically we may come to a conclusion that more light will result in more electrons, right? So that can be a logical conclusion that we can come up with. If you have more light, if you are shining more light, or if you are providing more light to something, you get more electrons coming out of it.
इन्जिनमा जति बेसी तेल हाल्छु त्यति बेसी एनर्जी आउटपुट दिन्छ
Exactly. We can come to a conclusion like that, right? It's very common for us to come to a conclusion like that. So to debunk all that, we have first law of photoelectric effect for a constant frequency of light, then more light will directly imply more electron. So this is the case where this is possible. So if you have a constant frequency, so light, the frequency of the light is not changing. So you are shining a single frequency light, a frequency of light which is not changing over time, or you are not changing the light source over time. So if there is a constant light source that is shining on the photoelectric emitter, then more the light, more the intensity of light, so this word has to be there, more the intensity of light, more is the electron that is getting emitted. So this is the first law of photoelectric effect. Any questions?
Clear.
Number of, yeah, so number of more electrons will be emitted with more light. Only condition is constant frequency of light. So light source has to remain the same, and this, the electrons that comes out as a result of light shining on a photoelectric surface is known as photoelectron. Right? So photoelectrons are basically electrons that come out of a photoelectric emitter when we shine light to it. Right? So those type of electrons are known as photoelectrons. So this is the first law of photoelectric effect. So is this clear? If you have any doubts till now, just let me know. So we did this. Yeah. And now to go further with this theory, with this frequency, we need to elaborate on frequency. So what we have is photoelectric effect. Photoelectric effect does not happen if the frequency does not exceed the threshold frequency. So this is very important. Why is this important? So you can say that, you can like easily say that your photoelectric system is rigged, because like you're shining light of high intensity on the photoelectric emitter, but still you don't find any current flowing through the circuit, right? But that is completely wrong. You can have whatever the intensity of light, you can have the highest intensity of light, but still if the frequency of the light is not met, if the frequency of light does not exceeds the threshold frequency, the frequency that is required by the photoelectric emitter to emit something, to emit some photoelectron, if that frequency level is not met, then the photoelectric emitter has doesn't have to emit.
त त्यो अब राति पनि त उयो हुनु सोलर चार्ज हुनु पर्यो नि त, किन भन्दाखेरि यो थिएन भने ल, किनभने यो इन्फ्रारेड त जहिले जहाँ पनि हुन्छ नि त।
एक्ज्याक्टली कस्मिक रेजहरु भइबस्छ,
कम्ती एनर्जी भएको फ्रिक्वेन्सीहरु हो नि त, वेभलेन्थ इलेक्ट्रोम्याग्नेटिक वेभ हो नि त।
Exactly. So frequency is a must factor for this. So you can shine jati intensity ko light, you can shine highest intensity light on the photoelectric emitter, but if it doesn't meet the frequency requirement, that is the threshold frequency requirement, right, it will not emit electrons, it will not emit photoelectrons, right? So the first thing is the amount of light intensity can depend on the amount of photoelectrons that is being emitted, but that will depend upon the frequency. So frequency needs to be constant. If for emitted light, if the frequency remains constant, the more the intensity of light, more is the photoelectrons that is getting emitted. Another thing, a photoelectric emitter will only emit electrons if the threshold frequency criteria is fulfilled. So only if the frequency is greater than the threshold frequency will a photoelectric emitter emit photoelectrons. Okay, so these two conditions are very important. This is also known as law of photoelectric effect. So these two are the laws of photoelectric effect, very important. You should remember this anyhow. So if you have any doubts, any questions, just let me know.